Good afternoon, everyone, and you're all very welcome to the fourth meeting of the College of Psychiatrists of Ireland Evolution and Psychiatry Special Interest Group. Our first meeting was on Darwin Day last year, February 12th, and our group has developed and expanded considerably since then. My name is Henry O'Connell, and I'm consultant psychiatrist with Laois Offaly Mental Health Service in Portlaoise, Ireland, and associate clinical professor with the School of Medicine at the University of Limerick. I'm also the founding chair of this Evolution and Psychiatry Special Interest Group. I would like to thank Helen Murray of the college for her enthusiasm and help in organising today's meeting, and to my colleagues and friends from all over Ireland who have taken an interest in and contributed to our group during the first year of our existence. And of course, it's my great pleasure to welcome today's esteemed speaker. Randolph M Nesse is Research Professor of Life Sciences and Founding Director of the Center for Evolution and Medicine at Arizona State University. He is also Professor Emeritus at the Departments of Psychiatry and Psychology and the Institute for Social Research at the University of Michigan. Randy is also the founding president of the International Society for Evolution, Medicine and Public Health. Randy is the leading international light in evolutionary psychiatry and medicine. And he has also been a great inspiration and support to our fledgling group here in Ireland, and we thank him for that. Randy has authored countless papers, book chapters, and several important textbooks in the fields of evolutionary psychiatry and medicine. You will find a huge repository of Randy's writing on his webpage, randolphnesse.com, categorized under different clinical conditions and other topics. His seminal book, Why We Get Sick with George C. Williams, was published in 1996 and launched his career. And his most recent book, Good Reasons for Bad Feelings, from 2019, is essential reading for everyone, clinicians or otherwise, with any level of interest in this fascinating field of evolution. Randy's talk today is titled, Why Hasn't Natural Selection Eliminated Mental Disorders? Knowing the 5 reasons improves clinical care as well as research. So thank you, Randy, and 100,000 welcomes, or to say that in Irish, Céad Míle Fáilte.
Thank you so much, Henry. It's very exciting for me to have a chance to talk with a new group developing the way this one is, and I'm very grateful to Henry and all of you for being part of this movement of bringing a basic science to psychiatry that badly needs it. And I should begin by just saying that, my task right now is essentially, I can't possibly explain everything about evolution and psychiatry in one talk. It's like saying, how is neuroscience useful for psychiatry in 40 minutes or something? It's impossible. What would be far better is if we could all sit around the pub and just chat, and I could give some introductory remarks. So what's fun for me and most useful is please start using the chat right now and put in any questions you have and thoughts you have and criticisms you have so that we can have a back and forth conversation. And Henry, I'd like you to keep an eye on that. And even in the midst of my talk, if you would kind of interrupt and bring up things as they come up, because that's what's fun and interesting about all of this. I will show some slides here. See if I can get the screen share to do its proper thing. So our topic is, why did natural selection do a better job? Why on earth did it leave us so vulnerable to mental disorders? And we begin by just, I don't know how you feel about it, but I just, the biggest problems the world has are mental disorders. And we are pretty good at helping that. It's an extremely satisfying profession and desperately needed. I wouldn't trade it for anything. I tried a lot of other things. I tried surgery, I tried other things, but psychiatry, I think, is by far the best in terms of interest and usefulness. But then there's the other side of our profession. It's the most confusing and controversial area, where newspaper columnists are always writing about psychiatry and saying, what's wrong with psychiatry? How can we reconcile that we're so useful and needed, and this is also confusing to people? If you go to the very first page, the leading American textbook about psychiatry, Kaplan and Sadok, it says, there's little reason to believe that these diagnostic categories are valid. Really? All the smartest people in the world work on diagnosis for decades, and this is the conclusion? Boy, that's disturbing. And Tom Insel ran the National Institutes of Mental Health here for more than a decade. What did he conclude? He concluded, whatever we've been doing for 5 decades, it ain't working. Maybe we need to just rethink this whole approach. With no validated biomarkers and too little in the way of novel medical treatment since 1980, it's time to rethink mental disorders. I mean, our schema, once we got past the simplistic version of psychoanalysis, which I admire in its subtle version, but once we got past that, we came up with a different schema, that we were going to find the bad genes, we're going to find the brain loci that cause problems, and then we would finally, be able to have good diagnosis and better treatments. It hasn't worked, has it? So what do we do now? So this is where I took my training. That's the University of Michigan Hospital. We had 30 people in the ward, just curtains between the beds. It was bedlam, really. And this little building at the bottom right, can you see my marker moving or not?
Yes. Yes.
That's the building where the Salk polio vaccine was developed. It's a wonderful place to do training. But what I experienced there was a wonderful diversity of perspectives. I had, professors who was existential psychiatrists and psychoanalysts and neuroscientists and pharmacologists and geneticists and cognitive therapists. And I found it very confusing. I didn't want to just be one of those. I wanted to use all the science we had. And it really felt to me like there was something missing. Indeed, there was. But I didn't know that until I wandered over to the Museum of Natural History. I was invited there to talk with some biologists who studied behavior. And I thought, well, biologists who study behavior, that should be useful for those of us who are psychiatrists. And early on in the first seminar I joined them for, they said, well, of course, every psychiatrist learns about evolutionary biology and behavior, right? And I said, well, no, not exactly. And they said, well, how can you possibly practice psychiatry without knowing the basic science? I said, well, shortly thereafter, it got more complicated yet. They taught me that every trait needs two kinds of explanation. One about how it works, proximate explanations. That's everything I learned in medical school. But they also need evolutionary explanations about why they are the way they are. And basically, they said every explanation of behavior is based on evolution. Wow, how could I not know that? Of course, psychiatry was left out. The question I had asked myself ever since my undergraduate days is, why didn't natural selection eliminate aging? So let me tell you, it was a wonderfully theoretical question back when I started on it at age 20. Now it's very acute and practical. I thought perhaps it was to benefit the species. I mean, if you kill off a certain number of individuals every year, then the species can evolve faster. Makes sense, right? And it's a good thing for the species to evolve faster. But when I shared this idea with these people, these proper biologists, they said, what? You don't know anything about evolution, do you? No, natural selection doesn't work that way. It only works for benefiting genes, not species. And they said, you need to go read this article by George Williams, Pleiotropy, Natural Selection, and the Evolution of Senescence, 1957. I got it on the way home, read it, and it changed my entire life. George Williams pointed out that aging genes persist, partly because some of them are outside the range of natural selection, but also because others offer early benefits greater than their costs. That's called antagonistic pleiotropy because it's opposite effects at different times in the lifespan. And so I spent about a year or two working on evolutionary theories of aging, going to the library and looking up all kinds of life tables for animals in the wild to see if there was evidence that the rate of mortality simply declined exponentially with every year, as it would if it was just the genes being outside the range of natural selection, or if at some point the mortality rate accelerated dramatically, as it does right here on this diagram. And lo and behold, for a lot of the species that I found, the mortality rate went down exponentially at first, and then it declined suddenly, or the mortality rate increased suddenly, and the survivorship declined rapidly. And that meant that George Williams was right, that a lot of the genes that cause aging are in fact beneficial early in life, and that's why they stay around even though they kill us. Wow, I mean, I had learned all kinds of things about aging in medical school, but nobody ever told me why those genes stuck around. This led to a natural next question. If we can explain aging, well, why not other diseases? Why do genes for schizophrenia stay around? Why is there cancer? My goodness, there's a whole world of things to be answered here. Why is the spine so problematic for so many of us? And why is it such a narrow ring of bone that babies have to go through to exit? What a stupid design. It would be so much better if we just installed a zipper so that babies wouldn't have such trouble getting out. So notice that this is an entirely different kind of explanation for problems. I mean, usually in medicine, we try to explain why one person gets sick and another person does not. But now we're trying to figure out why we all have traits that we share that make us all vulnerable to disease. Again, there's incredible perfection that we all study. Loop of Henle, it's astounding. The heart, the eyeball, the wrist, the clotting system, and my favorite of all, which I hated in medical school, I hated it, and I've come to love it, is intermediary metabolism and biochemistry. It's fabulous once you start understanding the trade-offs that shape those systems. Then there's botched designs that we start realizing once we get into clinical medicine. In the wisdom teeth, really? Why? The appendix again, the wrist breaks always in the same place. Why isn't that bone stronger? It would be very nice if our coronary arteries were just a little wider. And if that ring of bone was wider, and if our spine was better, but they're not. Why not? So this is a new question. Why do diseases persist? One obvious explanation is because selection just can't do better. Mutations happen. There's a random process going on here. But the next thing you think about, based on the aging idea, is that maybe diseases are somehow useful. And this is where George Williams and I started. We asked each other, how is breast cancer useful? How is schizophrenia useful? It turns out that this is the most serious and common mistake in evolutionary medicine and evolutionary psychiatry. This is viewing diseases as adaptations. They're not adaptations. This is just a mistake that is very important to avoid for everyone in this field. Even though there are lots of papers you can read about people claiming benefits from diseases. Here's the crucial insight that made it all possible. Diseases are not adaptations shaped by natural selection. They don't have evolutionary explanations, but traits that leave us vulnerable to disease, those were shaped by selection, and they need evolutionary explanations. So George and I wrote an article, George Williams, that's the same fellow I talked about, who discovered the cause of aging. We wrote an article in 1991, and then a book, Why We Get Sick. And they've caught on and led a lot of people to share our interest in asking these questions. So why did selection leave us vulnerable? First of all, the old thing we all learned in medical school is it has limits, mutations that can't start fresh. The second one that we've called new attention to is that it's slow. We're in modern environments where our old brains don't match very well, and we can never keep up with fast evolving pathogens. Here's a deep one though. Natural selection doesn't maximize health. It maximizes reproduction even at a cost to health. And finally, it maximizes performance of various traits, even if that means they're going to fail in some people. The last one's the most important for psychiatry. A lot of things that seem like they're diseases are actually defenses: pain, fever, nausea, vomiting, anxiety, and a lot of depression. So this is a giant shift in perspective. This is changing from a mechanic's description of what's going on. You know, how does it work? What's broken? How can we fix it? To an engineer's view about why is it designed that way? Why did they leave it so vulnerable to failure? And again, I'm going to pause here for a minute. I mean, what we all want as psychiatrists is ways to fix our patients right now. And we do need to understand as much as we can about how the mechanism works. But at this point in the history of psychiatry, I think we really need to step back and take an engineer's view. It's going to be helpful mostly for doing research, I think. But in the clinic, it's also immediately useful, as Henry O'Connell's book will show you if you have a chance to see that. So this is evolutionary medicine. Nothing alternative about it. It's just the intersection of a basic science and the profession of medicine. And evolutionary medicine is now growing nicely with an international society. Our meeting is in Lisbon in July, and an Oxford Press Journal, and programs and institutes for evolutionary medicine at about a dozen places around the world. And here's evolutionary psychiatry still getting started. It's a subset of evolutionary medicine. Evolutionary psychiatry, still just getting started. Brent Winograd wrote one of the very first early books, McGuire and Troisi, one by Simon Baron Cohen. And That's a group from the UK that you probably heard about, Evolutionary Psychiatry Special Interest Group, the Royal College. And these are other new books about evolution and psychiatry. That's mine, that is just out a year ago. One about cognitive behavioral therapy and evolutionary psychiatry, and a brand new one I recommend to you, Evolution and Psychiatry, Clinical Cases by your leader. So if we have a genuinely medical model, it distinguishes symptoms from diseases. It'll probably be better for you there. It investigates life situations to find the causes of emotions. It understands individuals as individuals, and then it relieves situations by doing whatever we can. And some people think evolutionary approaches are going to be kind of cold and heartless and make generalizations. But in my view, it encourages us to do what good psychiatrists have always done and even more. And that is understand each individual patient one by one. Here are books about animal behavior. Every one of them is based mainly on evolution and on the principle that brains evolved to maximize reproduction, even at the expense of health. Here are 6 different brains. They look alike, but they're not. They have small genetic differences, and those small genetic differences lead to small behavioral differences. And those differences result in some of those brains giving rise to more children than others. And that's why brains evolve to maximize the transmission of an individual's genes. Finally, we get to mental disorders. I'm going to talk today about emotions, behavior, and cognition, emotional problems, behavioral problems, and cognitive problems. There's a whole different lecture I could share with you another time about why relationships exist at all and why they're so difficult and why they arouse such bad feelings. So there's a sweet little office. I hope some of you have a sweet little office where you can see people one by one and spend time really understanding them, taking as long as it takes. I find I can't do it in half an hour or an hour. It takes me usually 3 hours to get a pretty good idea about what's going on in a person's life. But it's such satisfying work to actually do psychiatry the way it can be done best. At least I find it satisfying. And not just for people who in sweet little offices, with people who have more severe disorders in the hospital as well. But sometimes I look beyond the window of my sweet little office, and it's like a tsunami out there. And there are millions and millions of people everywhere who get no help from us. They're not, we can't begin to help all of them. And you have to ask yourself this other question, not just why did this person get a problem, but why is humankind so vulnerable to all of these problems? So we start with emotional disorders. Why are they so common? First of all, are they so common? They sure are. Here's from our world and data. Look at anxiety and depression compared with all of the other disorders. Overwhelmingly, as you know, what we see is anxiety and depression. And after that, we see drug use and alcohol. People can't control their behavior. After that, we get bipolar eating disorders and schizophrenia. But emotional disorders, that's where it's at. We have to ask, who the heck designed this thing? So many people feel so bad so much of the time. The answer is that emotions are usually symptoms, not diseases. Sometimes they can be diseases, but usually they're symptoms. Again, proximate explanations. How does it work? Why does this person experience anxiety? What chemicals, what neural pathways? Evolutionary explanations ask, why do anxiety and depression exist at all? How are they regulated? And especially, why are they so often useless? You have to go back to the really fundamental question about, so why are there emotions at all? Why don't we all just kind of go along, not changing our emotions at any time? And you see patients like that sometimes. Patients with alexithymia, they say, what's an emotion? What are you talking about, doctor? But most people that we see have extreme emotions. A lot of those emotions, pain, fever, they're like pain and fever and nausea and cough. They're shaped by natural selection to go off when they're useful, except they're also shaped to go off when they're not useful, which is a big problem. So the question that everybody used to ask is, what's the function of each emotion? There are hundreds of papers talking about the function of depression and the function of jealousy. That's the wrong question. I spent a couple of years just working on emotions to make sense of it, since that's what I was doing with my career, is treating people with emotional problems. And I finally realized that the right question is, in what situation is an emotion useful? Because it's the situations that shape emotions. That's the right question. And the answer there is that emotions are special states that improve coping in situations that influence fitness. People who don't have a panic attack when a lion is breathing down their neck don't do as well as people who do have a panic attack. In my study of emotions, I noticed that there were hundreds of papers arguing about whether there were a few basic emotions or more basic emotions, or whether they were dimensions from positive to negative and activated to passive. It turns out from an evolutionary view, that's really not the right way of looking at them. They evolved from each other. They're special states with overlaps between them that make them somewhat separate, but not completely separate. They have overlapping fuzzy boundaries. There are no distinct set of basic emotions. There are all these special states. And also profound from this diagram is that the two kinds of situation that shape emotions are opportunities, and those are positive emotions, and threats and loss, and those are negative emotions. Good reason why there aren't neutral emotions, or at least hardly any. Negative emotions exist because we often face risk or loss, and in those situations, they can be useful. In the face of risk, it's pretty easy to see that anxiety can be useful. In the face of loss, there's sadness, but very different. And here's an immediate insight from evolutionary approaches that low mood is not the same as sadness. When you lose something, you get sad and get over it because it's gone. But when you continue to try to do something that's wasting effort, that creates low mood, which is quite different. Then there are all of the other emotions, and another big point from an evolutionary approach is that we really should be assessing every one of these emotions for our patients instead of focusing all our effort on just anxiety and depression. So here are two common assumptions. One is that normal emotions are usually useful, and the other is that useless emotions are usually abnormal. Those seem sensible, right? Normal emotions should be useful because they were shaped by natural selection, and useless emotions should be abnormal. There should be something wrong with the brain. But from an evolutionary point of view, these are both false. Painful emotions are usually normal from normal mechanisms, but not useful in that individual instance. And I'm going to spend just a minute telling you the 5 reasons why, because they're quite useful to think about in the clinic. First is the smoke detector principle. Then because we live in modern environments, then because emotions are not actually for us, they're to maximize our gene transmission. Then there's sensitization, it's useful, but prone to go wrong. Then there's bad luck of bad sequences of experiences. It really changes how I view patients in the clinic. I used to think this person has useless anxiety, it must be there's something wrong with their brain. Not so. First, the smoke detector principle. And we all put up with smoke detector false alarms because we want to be absolutely sure that it goes off if there's even a little bit of a fire. So what about panic attacks? Well, they're useful if in fact there's a lion breathing down your neck, but what if there's just a little sound between a rock in Africa and you only have a wooden spear and you're trying to gather water for your family? Then, should you run away? Well, it depends. Depends on the probability that there's actually a lion behind that rock. It depends on the cost of the panic, false alarm that is, and it depends on the cost of harm if you don't run away. So let's put some numbers in there. Might be a lion. Should you run away? Well, it depends on the cost of panic. Let's call it 100 calories. Let's call it the cost of no panic if it's a lion. That's 100,000 calories. That's how much the lion would get from eating you. The ratio is 1,000 to 1. When I first did this calculation, I said, what am I doing? This is crazy. What? Then I realized it's optimum to flee whenever there's a probability of 1 in 1,000 or greater that the lion is there. And that made me realize suddenly that 999 panic attacks will be unnecessary, but perfectly normal, just like the false alarms from a smoke detector. This changed how I treated my patients with panic attacks. I helped to develop one of the first anxiety disorders clinics at the University of Michigan. And all of a sudden, I was a more effective psychiatrist. Instead of telling my patients, you have a brain disorder, it's a panic attack, so don't be ashamed of it, we'll help you. Instead, I started telling them, actually, it's a useful response you're having, but it's a false alarm. Instantly, some of my patients said, oh, that makes sense. I'm going to quit worrying about it. So the principles here are that false alarms are normal. And this is why we can block not just panic attacks, but pain, cough, fever, and nausea safely. This is the foundation for what most doctors do most days, is making decisions about whether it's safe to block a normal alarm response. This has big implications for psychopharmacology. A lot of people say, well, Dr. Nesse, you say that these negative emotions are useful, therefore we shouldn't interfere with them. Absolutely not. That's like saying we shouldn't interfere with pain from a broken leg, just because, absolutely, we should do it if we possibly can. So modern environments, we live in environments vastly different from those we evolved in. And as a result, from watching our Facebook feeds or even just reading the newspaper or watching all the advertisements we see around us, we realize that we're not as smart or as rich or as beautiful or as handsome or accomplished as all these other people, and we start feeling bad about ourselves. Modern environments in many ways make things worse for us. And among other things, we can eat things we shouldn't be eating too. Emotions, here's a very awkward one, is that emotions benefit our genes more than us. And did you ever notice the proportion of problems that we see in our patients that have something to do with sex and reproduction? I mean, it's huge. Freud was onto something really potent when he recognized that sex and sexual drives and inhibitions and problems have a lot to do with a lot of the problems our patients have. And there's no surprise, because those emotions are not, in fact, for us. They're all for reproduction, even at our expense. The next one is sensitization. These mechanisms often have a built-in mechanism to assess how much they're needed. So if every time you go to the watering hole, you encounter a lion, the whole system will make that system much more sensitive, and you'll have panic attacks much more readily. And that's a good thing. Unfortunately, that same thing can cause a positive feedback. Speaking of feedback, someone's microphone is out. Henry, maybe yours needs to be muted. There's a little feedback I'm getting here. And then there are unlucky experiences. If a person just by accident fails at 2 different jobs or 2 or 3 different relationships, they often give up, thinking that it can never work. And it's our job to help them recognize that their experience has not been accurate So how does this help in the clinic? And the first thing it helps us to do is to investigate the person's life situation in great detail. The second thing is to not assume that useless emotions are abnormal. A lot of them are normal, but still useless. It helps us to go ahead and block painful emotions, except when they're useful. And explaining the utility of anxiety and the smoke detector principle is invaluable for patients with anxiety disorders and can be helpful for depression as well. And also, when I'm giving patients antidepressants to stop their panic attacks, I used to say, take this drug, it'll help your panic attack. But that patients always would say, oh, is it going to just cover up my symptoms? And I said, well, no, they didn't believe me. But now I say to them, this medication is going to stop the useless panic attacks that are setting off a positive feedback cycle that keeps it all going. And if you take them for about 6 months, it'll reset the system so that it knows that the environment is actually safer. And that's just enormously helpful to patients. So low mood, depression, a whole different kettle of fish. Anxiety, it's easy to see how it can be useful. Depression, not so much. Notice that I call it low mood, not depression, because everybody assumes depression is abnormal and you can't fight that. Most of our training is about why some people get depressed, what's the mechanism, what's going on there. But our question here is why any of us have the capacity for mood variation at all. And the second question is, why is it so vulnerable to dysregulation? So why bother varying your motivation? Again, why not just go along with the same medium level of motivation at all times? The answer is that environments vary. There are good times when harvesting the crop before the big storm comes is really useful. There are other times when you're sitting in the middle of winter and there's really no point in doing much of anything. And those who do doesn't do very well. So mood tracks the propitiousness of situations. Propitiousness meaning the payoff per unit of energy invested. A good illustration of this is foraging. Pretend you're picking raspberries. How can you get as many raspberries per day as possible? Well, this is a marginal value theorem from Eric Charnov. And he points out that, first of all, you have to find a bush. That's the search time. So you spend this much time finding a bush, and then you start picking from that bush. And you're going to spend this much time on that bush. At first, you get a lot of berries and then fewer berries. And that's very high motivation. It's exciting to find a new bush laden with berries. And then there are fewer berries and fewer berries and fewer berries. And your motivation flags. And by here, you picked every berry on the bush and there's no point continuing. This person who picks every berry on the bush gets this many berries in this amount of time. And that slope represents the number of berries per hour. This person is a really ADHD type. This person takes just a few berries and then they go to look for another one and they don't do as well. The person who does the best is the person who picks this many berries and this amount of time and then moves on to the next one. And without the calculus, what's going on here is that the motivation system shifts so that you're interested in shifting to some other activity at whatever point the payoff for this activity starts to decline below the average payoff per minute. And this applies not just to berry picking, it applies to everything in our lives. I mean, our human attention span, I think it used to be an hour. Now it's sliding towards more like 20 minutes for most people, I think, thanks to social media. But our attention span flags because it's a good thing. You try to read papers all night. No, you can read papers for an hour or two, and then you want to do something else. And it's a good thing because there are other more valuable things to do. There are good times in life when you find a new bush quickly and get a big payoff. The more you stay out foraging, the more berries you get, the better it is. Alas, it's not always like that. There are times when it's very hard to find a new resource. The payoffs are small and rare, and the longer you stay out there, the more energy you waste. So what about situations like that? When costs are greater than benefits for all available actions, what's the best thing to do? You can guess the best thing to do is nothing. Don't just do something, stand there. So mood allocates effort to maximize getting resources, but it's not just berries. We spend our lives getting social resources, sex and status and friends and group membership and jobs and appreciation from people. These are the things that our mood guides us for. And I envision it almost like a rubber surface, and our emotions, the emotions are putting up and down, and we are balls kind of rolling around towards and away from things, depending on where the emotions pull us. And again, they're not doing it for us. They're doing it to get us to do whatever is good for the genes. Many, many articles talk about the function for depression. Is it a plea for help? Is it giving up? Is it sickness behavior, conserving resources? They're all worth reading and they all contribute. But again, they're in some ways pre-evolutionary views of depression. A different view is that we should look at the situations that make low mood useful. So what are those situations? The perfect depressogenic situation is quoted by William Blake, of all people. William Blake says, if any could desire what he is incapable of possessing, despair must be his eternal lot. So these are not new ideas. I mean, the Buddhists, of course, recognize the same thing, right? They say that desire is the source of all suffering. But for us and our patients, the depressogenic situation is one where people are trapped pursuing an unreachable goal. And that perfectly arouses bad depression. This is the crucial question that my residents tell me is the most useful thing I've ever taught them. Ask your patient, is there something you're trying to do in life that seems so important you can't give it up, even though it seems like you'll never succeed? And when I ask that question, I often find out things that I never found out, even from an hour of asking them, have you had stress? You know, how's your marriage? This question often and a long pause afterwards brings up things that otherwise you would never get. So what to do differently, thanks to your new evolutionary understanding? When you ask that crucial question, you consider all possible causes of an emotion. You use all possible treatments instead of just one. But most of all, you conduct a review of social systems to try to understand that person's life in more detail. So we all do a review of systems in medicine, right? We check, the cardiovascular system, the nervous system, the respiratory system. We ask questions that might indicate if there's a problem in any of those areas. But from an evolutionary psychiatry view, we need to be asking a review of social systems. And to make it simple, I've created a mnemonic, SOCIAL, to cover the 6 main areas of life resources that we all are constantly pursuing. Social support, friends, groups, status, occupation, and something that makes other people appreciate us, children, family, and relatives, income, financial security, abilities, appearance, personal resources, especially health, and love and sex. Going through these systematically, again, it takes a while. You can't just do it in a second. But without this, you're missing whole sections of a person's life. And here's why it's complicated. Every time you invest more in your children, you're investing less in your occupation. And every time you invest more on trying to find the perfect mate and having sex, you're investing less in your social life or your abilities. Every one of these intersects with each of the others. And this is why we lie awake at night, trying to figure out what to do, where to allocate our effort. And the thing that we need to understand is that there isn't any perfect solution. It's not possible to do everything for everything all the time. The choices have to be made. And it's best, I think, to lead a balanced life. But on the other hand, the people who succeed super big time often don't lead balanced lives. And natural selection has shaped us to want fabulous fame and wealth and other kinds of things, often at the expense of a balanced life. So again, these are the kinds of questions that we can ask about each area. What does a person have? What do they want? What plans do they have? How do they think they'll work out? We can figure out, but they won't tell us about the defenses that are often preventing their conscious apprehension of some of this. And what are their current concerns and emotions? This is a kind of in-depth understanding of a person's life situation that I think is crucial for understanding what emotions a person is having and whether those emotions are coming up for good reason or whether they're coming up just because the brain is different. And I'm going to pause here for a moment and say that for every patient we discussed at team meeting in the anxiety clinic, I try to keep tabs on whether it was mainly, that they were in a bad life situation causing anxiety, or mainly that they were just always that way and their brain was that way and they had the genes for it, or whether it was a combination. And it wasn't like everybody had something bad going on in their lives. A lot of them, it was just, they had anxiety like their mother and their brother and their grandfather, had nothing to do with what was going on in their life. But my conclusion was it was about a third, a third, a third. A third built in, a third a combination of built in and current situations, and about a third mainly having to do with current situations. On to the next topic. Briefly, why can't we control our eating and drinking? And the global answer to this is pretty clear. This is an article that Kent Berridge and I wrote some time ago. Novel environments offer steady access to pure chemicals, distilled alcohol and cigarettes and cigarette papers and heroin and needles. And those things go directly to our learning mechanisms and hijack them. Seems like it's just pleasure at first, but this whole system takes over the learning mechanism and gets people to keep doing things even when they really, really don't want to. And selection is way too slow to protect us from these dangers. And so we have gigantic epidemics of alcohol addiction and other addictions, and now maybe social media addictions as well. We have to ask ourselves about the variation in genetic vulnerability to addiction. A lot of people are looking for those genes as if they're abnormal genes. Are they really? No, I don't think so, because those genes didn't cause any harm back in ancestral environments when there wasn't pure alcohol or pure drugs readily available. I think a great research opportunity is to try to figure out how people who have those genes, and now you can do them with a polygenic risk score, how they forage differently or how they run their relationships differently. We shouldn't assume they're defective people with defective genes. We should recognize that they're different, using different strategies. Likewise, for eating disorders, these are really mainly disorders of modern environments. People didn't used to not eat to get thin because they were eating whatever they could, whenever they could, to make sure they nourished themselves. But what happens when you're in a modern environment and you see all around you images of delectably attractive, thin individuals, and they seem to be getting all the attention and the mates and the jobs? Well, you decide, hey, maybe I'll just stop eating for a few days and get to be thin like that. But that restrictive dieting arouses an evolved response, the famine response. And that response means that once you have stopped eating for a day or two, it doesn't matter what you decide to do, you're going to suddenly eat a whole loaf of bread or a whole half gallon of ice cream and then wonder, why did I do that? And then you're going to feel like, oh my God, I really am out of control. I've got to try harder. And worse yet, that kind of yo-yo dieting leads to a weight increase, which is useful in the face of erratic food supplies. That leads to still harder attempts to control it, leading to bulimia in many people and anorexia in a very few that are able to control their eating. This is not the whole story, but it really shows how an evolved mechanism for regulating food intake in combination with a modern environment, with attempts to compete sexually, to be more attractive than other people, and all kinds of food that makes most of us too heavy just because there's so much good food around, it leads to a vicious cycle that perpetuates. And against a vicious cycle, kind of like the one we saw for addiction. I mean, it starts off, not so bad, but before you know it, the more drugs you use, the more drugs you have to use. And it's a very nasty cycle. The last topic is really going to be covered extremely casually and quickly. It deserves a whole lecture to itself. And this is what I'm working on mostly now. It's fascinating to ask the question about why do genes for dire disorders persist? I mean, men with schizophrenia have half as many children as others, women about 20% lower than others, and people with autism, very few children compared with other people. OCD, I mean, these are dire disorders. They should be selected out. It was not too long ago that we were just able to sequence the genome, and we began to identify candidate genes for depression and schizophrenia. And people spent their whole careers, decades, trying to identify the genes that were responsible. It's a very hopeful time because we thought, finally, we know these are genetic illnesses. Who gets them and who doesn't depends mostly on what genes a person has. So let's find the bad genes. But here's a project done by one of my former graduate students, Matt Keller. For all those 25 genes, not a single one of them panned out when studied in a larger sample. Terribly disappointing. He further pointed out that all of these genes explain the exact same proportion of the variance. These ones over here are very common, and they increase your risk by about 1% or 2. These here are extremely uncommon, and they might increase your risk 5-fold, but all of them together explain about the same proportion of variance, about 0.04%. That is 0.0004. Why? Well, here's part of the answer. These alleles over there that would be common but potent almost certainly have been selected out. But can we be confident of that? No, we need more work on this. This is the other dramatic finding just from the last few years, showing that there's high genetic correlations between different disorders in psychiatry. I mean, back 10 years ago, we were thinking, we're finally going to find the genes and we'll have diagnostic categories based on the genes. No, the actual answer turns out to be that major depression and ADHD are massively overlapping, and major depression anxiety. I mean, the genes for generalized anxiety disorder and major depression are essentially the same. So no help there. As with schizophrenia and bipolar disorder have massive overlap of the genes causing them. I don't know what we do about this. So a group of us are trying to have a conversation about this too. I think the answer here is that we've been thinking not correctly about the body in general. We've been thinking it has modules and there are specific diseases with specific brain causes and specific genes. I think it's looking much more likely that the massive pleiotropy and the massive interaction of all the systems means that once natural selection tries to shape the brain to do something better, like language or relationships or things, it's going to screw up other things. But that's a whole nother talk. The word I'm working on now is intrinsically vulnerable systems of several different kinds that I think can explain many of these alleles with tiny effects it's thousands of alleles for schizophrenia, for instance. Did you know that the number of alleles on each chromosome that seem to be involved in schizophrenia is directly proportional to the size of the chromosome? It's like all genes all over the whole genome are contributing. We are just not thinking right about this. Here's one idea about how to proceed. This is the metaphor of the cliff edge effect. If you want to breed a racehorse for speed, what do? Well, you take all the fastest horses who win races and you breed them with other really, really fast horses. And it turns out that one of the things you get is a longer cannon bone, longer, thinner, lighter, and more likely to break. So essentially, this is reproductive success or likelihood that that horse will be bred. The only ones that get bred are the ones that are the fastest of all. But those that are the fastest of all have long bones that are really prone to breaking. So for other kinds of effects, and this might have to do, for instance, with human capacities for cognition or memory or relationships or just cognitive abilities and language. The maximum individual fitness will be right up there at the peak. Is natural selection going to keep that trait right at that peak? No, it's not. And here's why. The offspring of that individual, many of them will be off the cliff and be vulnerable to disease. So what does natural selection do? It pushes the mean for that trait down on the left-hand side of that diagram. And then the offspring of this individual has a mean there and a distribution such that only about 1% are off the cliff. Wait a second. That rings a bell, doesn't it? What percentage of the population has schizophrenia? About 1%. What percent has bipolar disease? About 1%. What percent has OCD? About 1%. All of these are very highly heritable diseases. So I don't think, and this is a vastly simplified idea for what I think is actually going on, which is a much more complicated interaction of multiple systems. But nonetheless, the point here is that natural selection does not shape us for health. It maximizes gene transmission. And this means that it shapes traits to the point that maximizes gene transmission, despite the fact that some individuals are not going to do well. So what we've been looking for is something very simple with boxes and arrows between them. And what we actually find now that we're getting the genome data is something much more like that. There's structure there, but it's so hard to see it. And it's not the nice, clean, neat kind of organization that we want. Again, we imagine that we are looking for an Italian garden, all beautifully laid out with brain modules and brain functions allocated to specific loci. But the truth of it is, it's a tangled bank. And I think we need to be accepting the tangled bank of evolved complexity to make progress. The bottom line here is that an evolutionary approach makes us more effective. And it certainly makes our work more satisfying because it gives us an idea about what we're doing. And really the bottom line here is that the rest of medicine already uses evolution in really related ways. That we know what the kidneys are for, we know what the adrenal gland is for, and that helps us to understand how they go wrong. Trying to ask evolutionary questions about emotions and behavior regulation mechanisms and cognition can help us be a lot more like the rest of medicine. With that, I will stop. I'm glad to see there are things in the chat. And we will carry on from here for another 10 minutes. And thank you so much, Henry.
Thank you, Randy. That was fascinating as always, and you managed to cover so much in such a brief period of time. I really appreciate that. I was just going to start off with one question, and then I'll go to the chat for other questions. But my question relates to clinical applications, and you know it's my area of interest right now. Right. The audience you have here are mainly clinicians, mainly psychiatrists, and I think some GPs as well. I have, based on your recommendation, put into practice the false alarm analogy with very good effect for people with anxiety disorders and panic disorders. You can almost see the light coming on in someone's eyes when you give them the explanation. And I'm just wondering, are there any other little tricks from evolutionary psychiatry that we could use in our everyday practice immediately, starting from next Monday, that you would recommend?
I hesitate to try any of them in a sentence or two, Henry, but I'll try. I mean, I think most of these need a much more, I mean, the cognitive behavioral therapy book, by the way, is about 800 pages. I think it's padded with too many sentences. But I think cognitive behavioral therapy benefits a lot from an evolutionary perspective, because you can help your patients recognize that a lot of the emotions they're feeling and a lot of the goals they're pursuing are not for them. They're for their genes. And that's helpful for a lot of people. I mean, you know, this idea of, you know, I mean, it comes back to sex a lot too. I mean, and you can talk about sex and why that's so problematic. And you're not going to be able to give up wanting sex, right? Because that's like trying to give up food. I mean, it's just built in. But a little bit of sense of humor about it, you know, I think is the key to getting through life for a lot of us. So cognitive behavioral therapy is one area. I think there's a big opportunity in psychopharmacology to explain to ourselves and to our patients about how drugs work. I mean, it's a, you know, telling people it's a chemical imbalance and the drug is going to solve the chemical imbalance. Well, that's false. I mean, we shouldn't be saying things like that. For drugs that work on emotions, I think what we should be saying is that, you know, most of our drugs work for bad feelings the same way that aspirin works for pain. You know, it doesn't solve this origin of the problem, but it blocks the mechanism. And that's perfectly safe and fine if we can do it without side effects that are too bad, because usually that pain isn't necessary or that depression or anxiety isn't necessary. So I think that whole attitude towards emotional disorders is very helpful for clinicians and patients. But Henry, I think we are all just getting started, and everybody on this call, I think, can contribute to helping us figure out ways in which evolution can contribute to clinical advances.
Thank you, Randy. So I'm going to then open it up, and the first question we have is...
Actually, I'm going to ask people if they would raise
Dr.
their hand. So let's let people raise their hands and ask live if they'd like to. And while we're waiting for those hands to go up, I'll let you read some of the questions from the chat.
Perfect. Okay. So the first one is from Dr. Mara Petrut, and she has asked, thank you, and it's an honor to attend the meeting. Psychiatry is the medical holy grail. Where do you stand on future gene therapy for mental disorders?
So, you know, gene therapy usually implies that we're going to use CRISPR-Cas9 to, you know, change our genes. That's already being done for sickle cell disease in some individuals, but we don't have anything like single gene effects that are large for any mental disorder. Do you know that? I mean, there is no single gene that reliably causes any mental disorder except for Huntington's disease. And then we have ApoE4 for Alzheimer's disease. But other than those, which are not usually thought of as psychiatric diseases primarily, there aren't any common genes with large effects. So I think, you know, we're not going to have gene therapy. I think we will get deeper insights. I can tell you the most important research project, I think, was just waiting to be done. I mean, we're now using polygenic risk scores that throw in all the information from a person's genome to predict the risk that they're going to get schizophrenia or that they're going to drink too much or the like. This is very interesting. This uses genes, they're not statistically significant in themselves, but we put them all together in one big equation. Here's the project. Stop just looking at those who have a very high risk score and look for those who have a really, really low risk score. What about the people who have the very lowest polygenic risk for schizophrenia? Are they perfectly healthy, stable people who are doing very well in life? Or are they people who are suffering some because those same variations that cause schizophrenia are missing, and therefore the person is missing the benefits from those? I predict that the people who have very, very low risk will be doing just fine, thank you. But for those people who think there might be advantages to those alleles, this can answer the question.
Okay, thank you. And I go on to the next question in the chat, which is from Jerry Rafferty. And Jerry has asked about, it's related to aging. Are demographics in Western society changing, and are we getting to the point where we can sustain society in the near future? Is this the unintended consequence of us interfering with a useful process, i.e. aging?
So we live a lot longer now on average than we used to in hunter-gatherer times, but aging proceeded at the same rate then as it does now, and people used to live to 70 quite reliably. So aging hasn't changed. It's just that we're protected against infection and accidents much better than we were before. And this results in epidemics of old age kind of diseases just because we're lucky enough to live to old ages. Plus, we eat different and don't exercise right, and we use antibiotics and do all kinds of other things that increase damage from atherosclerosis and diabetes and other kinds of things. So I don't know if that really answers the question. So aging, I should say, aging is not a useful process. I guess that's the most important thing to say. Aging is just the inevitable consequence of natural selection shaping systems to get maximum vigor early in life and maximum reproduction, even at the cost of aging later in life. Changes your view of aging too. That's really quite profound.
Would anyone like to ask a question live? If you do, just put your hands up, or otherwise I can just go on to the next one in the chat. If you want to put a hand up, if you want to ask live. Otherwise, I would go on. And
we only have 2 or 3 minutes left, so I'm sorry, I do have another meeting. I've got
2 or 3 minutes.
Just a minute there.
Yeah, that's fine. Daniel L., with the concept of the cliff edge of fitness, doesn't this imply that we should expect individuals of high fitness to genetically pass on a greater risk of disorder to their offspring, and so be more prone than others to have offspring who are just over the cliff edge and have the disorders?
I'm trying to see that question so I can read it again.
Yeah.
It was a little complicated. Which one is that?
So it's the last question.
With the Mara Petru, is it? No.
It's the very last one from Daniel L. With the concept of the cliff edge of fitness. Can you see that?
Yes, I can. And that you put your finger on the exact important thing about the cliff edge effect, which is that natural selection shapes traits to whatever level passes on genes the best. And it really doesn't care if there's some individuals who natural variation ends up leaving them over the edge. And I have some fancy population genetic models about that with a spreadsheet that just confirm that, yep, natural selection is going to leave most traits at a level that leaves some individuals not doing well. I've got to leave in 1 minute here, but in fact, I probably should leave right now. But the last question is that, are we evolving so fast now? What's happening now? I mean, what's creating natural selection strongest right now? It's probably drunk driving. That's what kills the most young people. So what's this going to do? I think it might shape less of a preference for alcohol in a few thousand years, or it might shape being able to drive quite well while drunk, and we can't tell. And on that note, I'm going to leave you, and thank you so much. I would appreciate any feedback, and send me a note by email if you like. Thanks so much for letting me join you.
Thank you, Randy. All the best. Thank you.